let's sketch the graph of this rational function f of x equals to x plus 3 divided by x minus 3 using this detail. So I would like to find the domain of the function, x-intercept, y-intercept, vertical asymptote, horizontal asymptote, relative maximum, minimum, and then analyze the concavity and then inflection point if they exist. All right, so starting with the domain of the function, so very quickly, what number makes the function undefined? The answer is x equals to 3, right? So for domain, you have to specify that x cannot be equals to 3, so x can be equal to anything else except positive 3. So therefore, the domain is from negative infinity to 3, and then from 3 to positive infinity. So that is your domain. And then x-intercept and y-intercept. So I'm going to use different colors to divide this up. So let's do a y-intercept first. So for y-intercepts, you are going to let x equals to 0. So you have y equals to 0 plus 3 divided by 0 minus 3, that equals to negative 1. So the y-intercept is 0 comma negative 1. Negative 1 is not an intercept. 0 comma negative 1 is an intercept. Intercept is a point. You have to provide the x and y coordinates. And then the next step, x-intercept, this time you let y equals to 0. So you have 0 equals to x plus 3 divided by x minus 3. So when you have a top divided by bottom equals to 0, first of all, the bottom cannot be equal to 0, right? So the only thing you have, the only chance that you will get a 0 is the top equals to 0, right? So x is equals to negative 3. So therefore, negative 3 comma 0 is your y-intercept. And then moving on to the vertical asymptote. So for vertical asymptote, you already see that in the domain. So for vertical asymptote, do you see that x cannot be equals to 3 because that makes the function fail to be defined. So therefore, x equals to 3 is vertical asymptote. All right, how about horizontal asymptote? So for horizontal asymptote, HA, so for horizontal asymptote, we have to set the limit. So limit as x approaches to infinity, x plus 3 divided by x minus 3. The reason we have to let x goes to infinity is because the horizontal asymptote affects the left end and the right end behavior. You have to look all the way to the right of the graph, and you have to look all the way to the left of the graph. All right, so that's why you have to do positive infinity and negative infinity. So since the highest degree of the exponent is equal to 1, we are going to divide each term by x. So the way we write this is, I will just write multiply. Let's don't use blue. Let's use red. I will just multiply 1 over x on top and then 1 over x on the bottom. So that means I am going to divide each term by x. So we have limit as x approaches to infinity, x divided by x, 3 divided by x, x divided by x, and then 3 divided by x. And then we have limit as x approaches to infinity. We have 1 plus 3, and then 1, oh no, 1 plus 3 divided by x, and then 1 minus 3 divided by x. As soon as x goes to infinity, then you have 1 plus 0, 1 minus 0, so you have a 1. So the horizontal asymptote is y equals to 1. So this is your horizontal asymptote. As x approaches to negative infinity, you get the same thing. Y approaches to 1. So the horizontal asymptote is y equals to 1. And then now we are ready to analyzing the slope, increasing, decreasing, right? And maximum, minimum if they exist. So for slope, let's switch to a different color. So for slope, this one, finding the f prime of x, you will be using the slope. So I want to make the video shorter. This time I'm going to leave the derivative parts to you. So I will just give you this f prime of x. I'm not going to show any word. I will just give you the answer. That is negative 6 divided by x minus 3 square. So you have to set that equals to 0. So how do we find this derivative? You use quotient rule, right? So quotient rule, what's the quotient rule? The quotient rule is gf prime minus fg prime divided by g squared, quotient rule. I'm going to leave this part to you. Why? You have to, which now you are learning sketching the graph. At this point, you should be very familiar with derivative and quotient rule. If you cannot do any derivatives at all, that means you are in the wrong lesson. You have to go back to the previous lesson to study your derivative. All right, so f prime of x, I'm going to go straight to the answer. That is negative 6 divided by x minus 3 squared, set that equals to 0. Can you solve for x? Are there any solutions? The answer is no, because negative 6 itself is not equals to 0. So negative 6 divided by whatever number you want will never equal to 0, right? Negative 6 divided by what number equals to 0? Tell me. No such thing, right? So there is no solution. So there are no critical numbers. So that doesn't look like C to me. So critical numbers. Then how do we do the sign chart without any critical numbers? Then you use the domain. So the domain, what's the domain? The domain is you make a cut at 3, right? So you make a cut at 3. So we have negative infinity to 3, and then from 3 to positive infinity. This is your test intervals. And then you are going to pick a value within each interval. So let's say x equals to 0 and x equals to 4. And then you are going to test that using f prime. So f prime of 0, that is equals to negative 0.67, and f prime of 4, that is equals to negative 6. This is negative, this is negative. That means the function is decreasing the entire time, in the entire slope. So do we have any max or min? Nope. So there is no max and no min, right? So x equals to 3 is not a max and then not a min. So x equals to 3 is just a vertical asymptote. You have to remind yourself. And then for the concavity, I'm going to do the same thing. So you take the derivative one more time. So you have f prime, and then you do a double prime. So f of double prime. So f of double prime using quotient rule. I am going to leave this job to you because you are learning curve sketching. You should be able to do derivatives. If you cannot do derivatives at all, please go back to the previous lesson. All right, so 12 divided by x minus 3 to the third power. Of course, the square gives you a fourth power, right? So you have to simplify the top, and then you will be able to reduce the fourth power by 1. So this one is also using quotient rule, and then you set that equals to 0. So 12 divided by what number equals to 0? The answer is no such thing, so no solution. That means there are no critical numbers. And then how do we do the testing? If you insist to do some testing, use the positive 3. So use positive 3 from negative infinity to 3, and then from 3 to positive infinity, I'm going to pick the same testing value, 0 and 4. So this time I will be testing using the double prime. So double prime of 0 and double prime of 4. So double prime of 4, that gives me a 12. 0 gives me negative 0.44. So negative, this is negative, and then this is positive, right? So negative means concave down. So concave down. Positive means concave up. That means x equals to 3 is a reflection point? The answer is no. That's why I picked this problem. So this is not a reflection point. So x equals to 3 is just a vertical asymptote. Just remind yourself, x equals to 3 is just a vertical asymptote. So now we are ready to do the graphs. So let me go ahead and do the graphs. So to do the graphs, let's set up the x-axis and the y-axis. So how about this? We are going to use different colors. So for the x and the y-axis, let's use pink. So this is my x-axis, and then my y-axis is right over here. And then this is my y-axis. And then what is horizontal asymptote? Look at what you wrote. Horizontal asymptote is y equals to 1, right? So we have y equals to 1. So this is my horizontal asymptote. So I'm going to write HA, y equals to 1. And then what about vertical asymptote? The vertical asymptote is what? The vertical asymptote is, we mentioned that so many times already, that is x equals to 3. So x equals to 3. X equals to 3 is your vertical asymptote. All right. Do we have any x-intercept and y-intercept? Yes, we do. So we have y-intercept at 0, -1. So this is a 0, -1. And then we have an x-intercept at -3, 0. So somewhere right over here. And then what about the graphs? So since we have a vertical asymptote, we want to test this. So, but if you look at the concave down and concave up, the graph should look like this. This is concave down, right? This is concave down. And you know what? This is, I want to make this nice. So this is concave down. And then concave up, this is concave up. And then how do I know x equals to 3? One side is going down, the other side is going up. This is easy. You have to test what happened when x approaches to 3 from the left. So when x approaches to 3 from the left, use the function. So we have x plus 3, right? So we have a 3 plus 3. You don't need to you don't need to worry about this. And then what about the minus? Oh, minus. You have something a little bit less than 3. So the top, I will just do a 6. That doesn't do anything. The bottom is what we need to know. So a little bit less than 3, just a little bit. Let's say 2.9999999. You take that, subtract 3, so you have -0.00000001. We talk about this situation in limits. So when you encounter this situation, that is equals to -infinity. So as x approaches to 3 from the right, you have 3 plus 3, and then 3 plus 3. Sorry, minus 3. Minus 3. A little bit greater than 3 minus that, then you have 0 point a bunch of 0. And then 1, this is a 6, so that gives you a positive infinity. So that's how I figure out the going down and going up when x approaches to 3 from the left side and from the right side. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like. Feel free to share this in any social media for me. If you are new to my channel, please take 2 seconds to click the subscribe button down below. I truly appreciate your help. I will see you all in the next one. Signing out.